Time-lapse of sun rising on a harbor. Graphic reads 2016 National Park Service Centennial. Graphic reads Find Your Park. Speaker is Alexis Fischer, graduate student at MIT WHOI.
My name is Alexis Fischer. I'm a graduate student in the MIT WHOI, so that's Woods Hole Oceanographic Institution Joint Program. I'm just finishing up my 4th year here right now, and I'm working on this toxic dinoflagellate.
Alexis, an assistant on boat clearing seaweed off marine instruments.
So it's a type of algae that produces these red tides or these harmful algal blooms, and they're rampant worldwide, but in particular in this kind of New England area. So my system that I work in is this salt marsh.
Sweeping pan of salt marsh.
This estuary that's part of Cape Cod National Seashore, and we have these blooms that have recurred. We've been studying them for about the last 30 years or so, and they've occurred about something close to 27 out of the last 30 years.
Camera dips underwater.
There are these blooms that are out there. It's something that they need to know about because we'll go ahead and eat this algae, and that's just what they do. They're filter feeders, and this algae has a very, very strong toxin in it. It's a neurotoxin. So when the shellfish eat this algae, they will in fact become toxic.
Sign reads toxic shellfish.
It's not really great for them, but they're able to ultimately expel the toxin from their body in about 2 weeks or so. It's a human health problem, really. When humans go ahead and eat the shellfish, they can get really, really sick, and that can oftentimes result in paralysis or even death. Every year, there's a shellfish harvesting closure.
Sign reads close to shellfishing.
Shellfish beds, when we have to close them, can really cause losses of millions of dollars for the local economies.
Sign reads no shellfishing.
So we need to know when to close these shellfish beds.
Marsh front cabin in the sun. Assistant starts boat's engine. Cruising on a boat through the marsh.
Today we're doing this really fantastic thing called the post-bloom cyst survey. So what are cysts, first and foremost? Cysts are really the seed-like version of this algae that we're studying. Basically, the algae will germinate from this cyst, very similar to you have like a plant that germinates from a seed.
Alexis drops a coring device from boat to harvest cysts.
And ultimately, if conditions are right, it'll produce a bloom that will be, something like 100,000 cells per liter up to 1,000,000 cells per liter. And that's why we call them red tides, because the blooms are so dense that it'll actually discolor the water red. We have been doing these cyst surveys since October 2012. I love the aspect of this work where I get to really get my hands dirty.
Alexis wearing waders in muddy marsh cleaning out core tubes.
And it's not the white lab coat, sterile gloves sort of thing. I mean, granted, I do some of that, but I get to do a huge gamut of things, running from just being in the mud for days, and then I'm modeling something on my computer. So it's fun.
Alexis wearing wetsuit collecting samples in shallow water.
This type of science is very important because there have been more reported incidences of them worldwide in the past several decades. It is really a natural occurrence. So we just have to be able to manage our waterways more successfully so both of these toxic algae and humans can really live there together.
Graphic reads, this has been a production of NPS National Resource Stewardship and Science in association with Colorado State University.